Hi, today we will talk about perimeter and area, mostly about area, because perimeter is pretty simple notion. The perimeter of a triangle is the sum of its sides, A plus B plus C. For rectangle, the perimeter is also the sum of its sides, A plus B plus A plus B, or it is perimeter equal to 2 multiplied by A plus B. For quadrilateral, the perimeter is also the sum of its sides, A plus B plus C and plus D. For any shape, the perimeter is the length of its border, and we are talking about closed shapes. Now about area. Formula for the area of a rectangle is its width multiplied by its height. In this case, it is 8 multiplied by 6. It is the number of small squares of area 1 each. There are 48 such squares. When you understand formula for rectangle, it's easy to understand formula for a triangle. It is equal to the length of its base multiplied by its height over 2, because area of a triangle is half of the area of the rectangle. Similar to rhombus, its area is equal to the product of the vertical diagonal by horizontal by diagonal, and over 2, because this pink area is half of the area of the big green rectangle. A question for you: is this formula valid only for rectangled triangles, or is it valid for any triangles? Jade, yes, you are right. It is equal to any of them. Good intuition. We will not prove it now. We will solve the problem. The area of the triangle is 24. The area of the base is 6. What is the area of the height? Yes, John, 8. Why? Because 6 by 8 over 2 is 24? Yes, it's right, you just guessed. We can solve it with the help of formulas as well. It is a doubled area is equal to base multiplied by height. So height is equal to double area over base. And when you substitute all values, you will have the answer 8. In this case, you don't need to guess. But your way of solving is also okay, because in this case, it's kind of obvious. Next problem about triangle ABC. Point D is the middle point of the base. We know the area of the blue triangle, 8, and we are asked about the area of the entire triangle. No, it's not 4. You divide it by 2. We have to multiply by 2, because they have, this blue and green triangles have equal bases and the same age, so their areas are equal, and the total area is 8 plus 8, or 16. Now I will tell you several rules which will help you solving Olympiad problems. Consider Egypt triangle with sides 3, 4, and 5. The area of this triangle is 3 by 4 over 2 or 6. Now consider another triangle which has all lengths 3 times longer than the previous triangle, sides 9, 12, or 15. The area of this triangle is 54. It is 9 by 12 over 2, 54. It is 9 times greater than the area of the previous triangle. So similarity rule tells us that if we increased all sizes of the shape n times, then the area of the new shape is equal to the area of the original shape multiplied by n squared. For example, if you have equilateral triangle with sides 1, 1, and 1, and you know that its area is equal to square root of 3 over 4, then the question, what would be the area of the equilateral triangle besides A, and A? Yes, JD. Yes, correct. It is, I need to multiply it by A squared because of the similarity rule. And the answer is A squared multiplied by square root of 3 over 4. The next rule is Heron formula. We use it when we know the sides of the triangle ABC. The rule says that area is equal to square root of the product of 4 numbers: s, s minus 1, s minus b, s minus c, where s is equal to the half of the perimeter. So s is equal to 9 plus 12 plus 15 over 2, 21, 36, 18. So area is equal to the square root of 18 by 18 minus 9, 18 minus 12, and 18 minus 15. It is square root of 18 multiplied by 9, by 6, and by 3. It is square root of 18 multiplied by 9 multiplied by 18, which is 54. It is the same as we already had. So this formula works for this case, and it works for any case, for general case, but we will not prove it. We go to the sliding rule, number 3. Just solve the problem to understand how it works. We have a triangle ABC, area 16. We have midpoints D and E, and BF is equal to 3. What is the area of the shaded triangle? Any ideas? Yes? Yes, John. You want to consider the third middle point. It's a good idea. If we consider the third middle point, M, and connect all middle points, we will have 4 rectangles. All of them are equal because they have equal sides. So area of each rectangle is 4. And one of them is interesting to us. Which one? Yes, John, blue. Why? Yes, because this blue triangle and our triangle have the same base, DE. And what about the heights? The heights are also equal because DE is parallel to BE. C. So these two red intervals are equal. It means that the area of our triangle is equal to the area of the blue triangle, which is equal to 4. So the answer is 4. But why we call this rule sliding rule? Because it says if we have triangle, for example, DEF, then we can slide point F along the line which is parallel to the base DE, and while we are moving this, sliding this point along this line, the area of the triangle is not changing. The position of point F does not affect the area of the triangle DEF. Let's solve the problem on this rule. We have two rectangles, horizontal and vertical, and we have blue area. Find this blue area. And because yes, do you have any ideas? Yes, it's on sliding rule. So we need triangles. Yes, your idea is good. Create two triangles. We will create two triangles, green and yellow. Find their areas and add them up. We start from the green triangle. We take its vertex and drag it down until it coincides with the vertex of the rectangle. And at that moment, we understand that the area of the green triangle is 5. Then we take the vertex of the yellow triangle and drag it to the right until it coincides with the vertex of the vertical rectangle. And at that moment, we understand that its area is equal to 5, and the area of the blue region is 10. Next rule, decomposition rule. We have square with area 60. Points A, B, C, and D are middle points of this square, and they form new smaller square ABCD, red one. What is the area of this small square? JD? Yes, it is 30. Why? Obvious. I agree, but we still prove it. We will prove it. And we will give two proofs. First one, by using formulas. We notice that this smaller square is at the same time a rhombus with horizontal diagonal equal to D and vertical diagonal also equal to D, which is the side of the big square. So D squared is 60, but the area of the rhombus is D squared over 2. So the area of the smaller rectangle is 30. And the second solution is about decomposition rule. We decompose big square into 4 small squares. And then we decompose each square into 2 triangles, like pink and yellow. They have equal area. So pink triangle is half of the small square. And we do it for each small square. And after that, we understand that the area of the smaller square is equal to 30. Let's solve the problem on this rule. We have a ruling paper with the side of the cell equal to 1. And we have some shaded area here. What is the area of this region? We will decompose the original shape into four pentagons: red, blue, yellow, and green. And then we'll decompose each pentagon into three equal triangles: 1, 2, 3, 4, and 5. Area of each is 0.5. So the total area is 4 number of pentagons by 5 number of triangles by 0.5 area of one triangle, and it is equal to 10. Next rule, crossover rule. It says that if you have a rectangle made up of 4 other rectangles, for example, with areas 10, 20, 12, and let's say x, then x multiplied by 20 is equal to 12 multiplied by 10, and we can find x from this equation. It is 6. For quadrilateral, the same crossover rule says that if we have 4 triangles with areas A, B, C, and D, then area A multiplied by area C is equal to B multiplied by D. Let's solve problem on this crossover rule. We have big rectangle. It is made up of several smaller rectangles with areas 12, 24, 42, 9, 18. But we don't know the area of the red rectangle, and we have to find it. And let's start solution from representing this red rectangle with 2 white rectangles. And I wrote that area of upper is x and area of the bottom rectangle is 2x. Why I wrote 2x, Emily? Yes, because 18x should be equal to 9 by 2x. But we don't know x yet. So we need to find something which we can use. John? Yes, we can use the 24 is twice as big as 12. So area of upper big rectangle is equal to the area of the twice area of the bottom big rectangle. We can write it down that 42 plus 9 plus x is equal to twice 18 plus 2x. 42 multiplied 42 plus 9 is 51 minus 36 is 15. And what is at the right side? 2x minus 4x. 4x minus x is equal to 3x. So we found that 3x is 15, and this is the answer to the problem. Let's go to the last rule which I was going to talk today. It is trapezoid rule. It is a trapezoid rule. We have right-angled trapezoid and diagonals there. Which area is greater, green or pink? Yes, Minilai? the same. How did you know? Just guessed. But let's see why. Consider two triangles. One of them is made up of two other triangles from the green and blue. And the other triangle is made up of other two triangles, blue and pink. They have equal area because they have the same base, which is the base of the trapezoid, and they have the same height. So green plus blue is equal to blue plus pink. We cancel blue and see that green area is equal to pink area. And let's solve problem on this rule, actually on combination of two rules. We have rectangle and four lines. 1, 2, 3, and 4. And we know areas 9, yellow areas 5, and 6. And we need to find areas X, Y, and Z. And how do we solve? Yes, John, X is equal to Y, of course, because of the trapezoid rule. What else can we use? Oh, formula for area of the triangle is base by height over 2. So this green plus yellow triangle is half of the area of the entire rectangle. So let's write it down. X is equal to Y, and we know that Z plus X is half of the area of the rectangle. And what left? What is another half? It is 9 plus 5 plus Y and plus X. We cancel Y and X because they are equal, and we have that Z is equal to 9 plus 5 plus 6, or 20. And now we use crossover rule, this one, that 5z is equal to xy, or to x squared. So x is equal to y and is equal to 10. So now we considered 6 rules which will help you in solving Olympiad questions. Any questions? No questions, so we go to the homework. Homework is not very simple problems. Actually, they are kind of difficult. For example, first one, a square is split into 5 rectangles with equal areas. What is the area of the square? It's not very simple. So I give you hints. These are hints. And I give you the answer. And your task is explain me how I arrived to this answer. Next problem. It's also the problem of Katrina Eck. It says 4 squares and an isosceles triangle. What's the blue area? And we know the side of the big square, 3. Once again, I give you hints and I give you the answer. And the task is the same. Explain me. The third homework. I have triangle. There is a median, and the line which divides this median into two equal intervals. I know the area of the yellow part. What is the total area of the triangle? Once again, I give you hints, I give you the answer, and you need to explain me how I arrived to this answer. And finally, the last problem. I have a square with side 4. I have triangle and I have a circle as it is drawn here. What is the area of the triangle? And I don't give you written hints. I just made some additional lines. And you need to explain me why the area of the triangle is 8. Any questions? Okay, no questions. Yes, thank you. Bye. Bye.